Welcome to this webinar on the reassessment of the safety of styrene for the use in food contact material. My name is Sandra Rainieri, and I am the team leader of the food contact material team at EFSA in the food ingredient and packaging unit. And I will open this webinar introducing also the other participants. After me, we will have a presentation from Zainab Alarak, who is the scientific officer who was in charge of coordinating the mandate in EFSA and of developing the opinion. After that, we will have a talk from our expert, Riccardo Crebelli, expert in genotoxicity, who had a pivotal role in this assessment and is involved in the working group of food contact material, as well as in the food contact material panel. And after that, the meeting will be closed. I would like to give you some housekeeping rules. This event is a one-way audio communication channel, which is in the listen view only mode. It is held in English, and I would like to remind you that it will be recorded, and the recording will be uploaded to EFSA webpage in the next few days. Shortly after this event, you will receive by email satisfaction survey that we strongly encourage you to fill in to help us improve our services. Now, a few details on this webinar. We have received 449 registration, and the registrants came from 55 countries. Most of the registrants were from the private sector, but they also came from university, public research institute, national and international organization, other agencies, and include also some EFSA panel members and network members. The objective of this webinar were to explain to the general public and to everybody interested the work that we did, starting from the mandate, explaining the methodology and the rationale that was followed in the assessment, and also describing the assessment and its conclusions. We would also like to highlight the fact that there is an ongoing public consultation on the draft opinion, that it is still open and for which you can provide some comments. And we will give you some guidance on that in the next few slides. If you remember, when you registered, you were asked if you had any questions for us. So the objective of this webinar is also to address the question that you might have asked at the moment of the registration. We actually have received at the moment of the registration 11 questions and comments from you, and we tried to address most of them, most of those that were in fact pertinent to the topic of this webinar, directly in the slides that are that will be following in the presentation that you will see in a minute. I want to highlight the fact that we also received questions that were not directly in the remit of this webinar. We received some questions on the specific migration limit measurement and calculation, for example, and this information will be given, but it can also be found in the link that we provide below on the EC Regulation 10/2011 and in EFSA Note for Guidance. We also received some questions on risk management measures, and this is really not our remit, so we kindly ask you to address this question to the Commission and to the risk managers. And some of the questions were out of scope of this webinar. They were not clear, they were on other topics that were not directly on the safety reassessment of styrene. So these were not addressed. In any case, if you find in the following slides that your issues were not addressed properly, we kindly invite you to submit your additional question either to the draft opinion while it is still in public consultation, or through the channel of Ask a Question service that we have for EFSA. You can find the link below, and these slides, as I said, will be shared with you shortly after the meeting. But we will now start directly going into the topic of today, and I will pass the floor to my colleague Zainab Al-Arrak that will introduce you to the mandates that we received from Commission on styrene and will describe the EFSA approach and risk assessment methodology that were used for this assessment. Zainab, the floor is yours.
Thank you. Thank you very much. Thank you very much, Sandra, and good morning or good evening, depending on when you are. So yes, I will give an introduction to the genotoxicity assessment of styrene by presenting some background information on styrene, on the mandate that we received from the Commission on styrene, and also the EFSA's approach and the methodologies that were used to perform the assessment in EFSA. So first of all, as you might know, styrene is a chemical substance authorized without a migration limit or any other restrictions of use for the manufacture of plastic food contact materials. It is indeed in the high priority list of substances that need to be reevaluated. In 2018, the IARC, which is the International Agency for Research on Cancer, has evaluated the carcinogenicity of styrene and its primary metabolite, which is styrene 7,8 oxide, and classified both substances as probably carcinogenic to humans, placing them in the group 2A. And this information is available in the IARC monograph, volume 121, published in 2019. Therefore, the Commission at that time requested EFSA to reevaluate whether the evidence examined by IARC could be of consequence to the safety of use of styrene in food contact materials. And that was the mandate sent to EFSA in 2018. So, and here EFSA comes into play, and at that time, the SEP panel, which is the panel on food contact material enzymes and processing aids, has decided to address this mandate in two phases. In 2020, EFSA has published an opinion where the panel has assessed the impact of this evaluation by IARC on the use of styrene in food contact materials, and more precisely regarding the genotoxicity potential of styrene. And they have considered that this evaluation is actually based only on high-dose occupational exposure studies and on animal studies by inhalation, and pertains therefore only to hazard identification and not to hazard characterization. Then they also stated in the opinion that actually an analysis of the reliability and relevance of all available experimental and human findings on styrene, together with toxicokinetic aspects, should be considered. So some data were missing, and that opinion was not conclusive and needs to be complemented. So you can find in the conclusions of the 2020 EFSA opinion that the SEP panel stated that the concern for genotoxicity associated with oral exposure to styrene cannot be ruled out, and a systematic review of genotoxicity, mechanistic data, TK, and analysis of species difference is necessary to conclude on this issue. In fact, for this reason, we received in May 2023 the second mandate from the Commission, where they asked to conclude on this issue and to establish whether styrene is genotoxic following oral exposure, and whether the use of styrene above an SML of 40 ppb can be authorized. I would like to mention something about this SML of 40 ppb. It's just a precautionary measure established and proposed by the Commission based on a guidance value determined by the WHO for drinking water in 1993. So the Commission estimated this 40 ppb, SML of 40 ppb, based on this value, and also a 10% of allocation factor to take account of other exposure routes. Another information I would like to say here is that this SML of 40 ppb will be taken into account by the Commission later on in the context of the requirements of the EFSA Note for Guidance for the application for food contact materials, to which I have included at the bottom of this slide a reference that you can check. To address this mandate and to give a consolidated answers to the questions of the Commission, it was decided to base the assessment on different data. First of all, genotoxicity data, of course, but also toxicokinetics data and human exposure, human biomonitoring data and dietary exposure. The sources of this data come from three different sources: the IARC monograph, published 2019, and the studies, some studies we received from the US Styrenic Information and Research Center, and also from a dedicated literature search that we performed, covering the time span from the end of the evaluation of IARC in January 2018 until October 2024. This slide shows only some information on the protocol and the methodologies used to perform the assessment. First of all, the literature search methodology is based on standard EFSA guidance documents, the one from 2010. 3 different databases were used to perform the search: PubMed, Scopus, and Web of Science for collection. Inclusion and exclusion criteria were also determined. For example, language should be only English. The time frame, as I said, the last 7 years, and the type of evidence, primary and not secondary papers. And then different search terms or keywords were also determined by the working group who was responsible of this assessment with regards to the 3 categories of evidence: genotoxicity, toxicokinetics, and human exposure. And the title and abstract and the full text screenings were the 2 activities that were performed in Distiller systematic review tool to perform the screening of the papers. All the genotoxicity studies were evaluated for their reliability and relevance according to harmonized EFSA criteria, and for this I will dedicate a slide after this one. And the toxicokinetics and human exposure studies were evaluated using a narrative approach. So regarding the genotoxicity studies, 2 criteria were used to base this assessment. The reliability of the studies is based on Flemish criteria and on other parameters, for example, the compliance according to the protocols in the OECD test guidelines. And it was classified as reliability without restrictions, with restrictions, insufficient reliability, or not reliable, the study. While the relevance of the study results, ranked as high, limited, or low, considers both the reliability of the study and also the relevance of the test system. All the studies results with sufficient relevance, high or limited, were the only ones that were integrated in lines of evidence in the and assessed in a way of evidence approach. While the information, for example, from mode of action, from in vitro studies or human biomonitoring or toxicokinetics, were considered only as supporting information in the way of evidence. This is just to show you an example of a table where you can find also in the draft opinion on styrene, where all the information regarding the assessment of reliability and relevance of the studies is included. So you can see from the left side to the right side, the test system or test object, or the information on the exposure conditions, so the dose, the concentration, the route of administration, then the information of the test substance, styrene, the substance purity, the results of the experiment, and then the judgment of the experts on the reliability, and also the reasoning why this is reliable and why it's scored as 2, reliable with restrictions in this case. Then the relevance of the test system or the relevance of the results. Again, here you have also the comments or the reasoning why this is relevant. And then the last column is on the reference of the study. This slide is just to introduce you to the next talk, which is basically the core of the opinion, the assessment of the genotoxicity of styrene, that will be given by Riccardo Crebelli, who is the member of the FCM working group and also at the FCM panel. Thank you for the attention, and I'll pass the floor to Riccardo.
Thank you, Zainab, for this presentation, and good morning, good afternoon. Welcome to all the attendants to this webinar. In the following slide, I will give you a brief overview and a summary of the experimental data considered by the EFSA FCM panel in the recent reassessment of styrene genotoxicity. As anticipated, 3 packages of data have been considered. First, the published in vivo genotoxicity studies evaluated in the IARC monograph. And here you see in one and in the following slide, we have grouped the studies according to the main genetic endpoints. For chromosome damage, that is chromosomal aberration and micronuclei, The IARC monograph considers 14 published studies, which are listed here in these two slides. Today, there is no time to discuss individually all of these studies. This has been done in detail in the draft, in the opinion. For the purpose of this presentation, it is, I think, sufficient to go directly to the summary of the evaluation which has been drawn in the opinion. As anticipated, all the studies have been carefully evaluated for the parameters of reliability and relevance, which determine the inclusion of these results in the weight of evidence. For what concerns studies reporting effect on chromosome damage, chromosomal aberration, and micronuclei in the IARC monograph, 15 studies were available. 10 of the 15 were considered sufficient relevant for inclusion in the weight of evidence. As anticipated, only studies with high and limited relevance are included in the weight of evidence. In these cases, no highly relevant study was identified. 9 of these studies with limited but acceptable relevance provided negative results. There was one study reporting positive results for the induction of micronuclei in polychromatic erythrocytes of mice following the intraperitoneal administration of styrene. This study was considered of limited relevance but acceptable to be included in the weight of evidence. It is notable that 2 studies have been excluded, not considered further. 2 studies which, however, are listed as positive in the IARC monograph. This we need to, for transparency, also to give some more specific consideration to these 2, which are a publication by Norpa in 1981, which was given low relevance because of the inadequate protocol and inconclusive results based on the current evaluation criteria, and a more recent paper by the Vodicka group, which also was given low relevance because of the insufficient reliability and especially because of the demonstrated lack of reproducibility of the results in a subsequent study by the same research group. And in next slide, you see the studies, published studies on DNA damage, primary DNA damage evaluated by the COMET assay. I will come back later on the significance of this COMET and other points. Well, anyway, this study concerned the possible induction of primary DNA damage, in particular single-strand breaks in DNA, in rodents treated with styrene with by different exposure routes. There are 4 publications. Out of these 4 publications, 3 were considered of sufficient relevance for the inclusion in the weight of evidence. One of these 3 showed positive results. It was a study again in which styrene was administered by the intraperitoneal route, while negative results were reported in 2 inhalational studies in rat leukocytes. One study was excluded because given low relevance, and this was one study that was reported as positive in the IARC monograph. Again, it is a paper by the Vodicka group, which was given low relevance because of the inadequate protocol and the inconclusive results based on current evaluation criteria established in OECD technical guidelines. There are other in vivo studies which are listed in the IARC monograph and which also were considered but given less relevance in the weight of evidence. These are these are an unscheduled DNA synthesis test in rodents and some sister chromatid changes. Oh, thank you for coming back to the previous slide. These studies were given less relevance for basically for two reasons. One is the established lack of sensitivity of the rat liver and shadowed DNA synthesis, and the other one for the sister chromatin with the changes is the uncertain mechanism and not established biological relevance in human risk assessment. Therefore, this study was not excluded, but considered in a narrative way only as possible supporting evidence. Well, the second package of the core studies consists of unpublished studies which were submitted by the Styrene Information and Research Center. Next slide. Well, these studies are of particular relevance for two reasons. One, because they are recent studies performed according to more robust and agreed criteria. And but secondly, especially because these are 4 studies performed by the oral route. You have noted that in the previous presentation about the IARC studies, the large majority of the studies, all except 2, were performed using route of exposure different from the oral one, that is intraperitoneal or inhalational. Here we had 4 studies in which styrene was given by the oral route, which are of particular relevance for this reassessment of styrene, which following the request in the term of reference of the Commission specifically concern the hazard posed by the oral exposure to styrene. The first 2 are combined PGA micronucleus and COMET studies in mice and rats. You see that in these studies, 2 different strains of mice and rats were used. These are the B6C3F1 mice and Fisher 344 rats, which are particularly interested for styrene because are the same strains which have been used in the NCI carcinogenicity study with styrene. In particular for the mice strain, this is the strain in which lung tumors were observed after oral exposure to styrene. Lung tumors for which the mechanism is actually now largely debated. Well, there is an attempt in this combined study to combine in one single study different genetic endpoints in order to have information to more different mechanisms. Very shortly, you can see in the next 2 slides, okay, what these endpoints are. For the PGA, this is a genetic systems which allow to identify gene mutations induced by treatment in the erythropoietic cells of rodents during an extended treatment. And in the same cell type, the micronucleus, which is concurrently performed in the same study, allows to detect different genetic effects, that is clastogenicity or chromosome breakage and chromosome loss or aneuploidy, which both are visualized as a deformation of micronuclei. In this way, with these 2 endpoints, you may have information on all most important genetic effects, that is mutagenicity, clastogenicity, and aneuploidy in one study in a specific cell type, that is the erythropoietic cells. In the same experiment, and next slide, also it was combined with a further assessment of another genetic endpoint, which is not a final mutagenic effect, but a so-called primary DNA damage, that is DNA lesions which may result eventually in permanent genetic damages. These DNA lesions, which are mainly single-strand breaks produced by treatment or as the effect of DNA repair or for the processing of alkaline labile sites are detected in this so-called comet assay, which is an electrophoretic based technique which can be applied in a variety of tissues. And this, the combination in one study of also this endpoint allows to assess a variety of genetic effects also in tissues other than the erythropoietic cells covered by the PGA and micronucleus. Well, I go shortly now to the results, where here is firstly a snapshot on the protocol of the studies. This is just to highlight that there are specific OECD technical guidelines for each of these tests, the PGA, the micronucleus, and the COMET, and the studies was compliant with the recommendation of these technical guidelines. And in this, the mice study, the styrene was given 29 days to a range of doses, in which the highest dose was the maximum tolerated as determined in a preliminary dose range finding study. Importantly, for these endpoints, and there was also the assessment of the internal exposure by the sampling of blood around treatment, which is most important for the assessment of effects in tissues different from the site of contact. Based on this study protocol and on the presentation on that, the study was considered reliable without restriction. And the results are shown here. For the PGA and the micronucleus, they were negative and considered of high relevance because the study design was compliant with the relevant OECD guidelines, and because the result was consistent with the laboratory historical data. Also for the COMET assay, the results were negative and considered of high relevance in liver, lung, kidney, and stomach. Study protocol also in this case was compliant with the OECD guideline with an adequate response of the positive control. And inconclusive results was obtained in duodenum, in which a high baseline, high background value was observed. And this prevents a proper evaluation of data, and this inconclusive results was given low relevance. A similar study was performed using rats instead of mice. Again, as a book, and in the previous one, you see that there are specific OECD guidelines. The study also in this case was largely in agreement or totally in agreement with the recommendation of the guidelines. A slightly different dose range was applied because this also was determined in a dose range in preliminary study in order to reach the maximum tolerated dose, which for rats was slightly higher than for mice, 500 instead of 300 milligrams. Also in this study, there was the sampling of blood after treatment in order to assess internal exposure, which is pivotal for the evaluation of the relevance of the results, especially for sites, tissues different from the site of contact. Also, the study was considered reliable without restrictions, and the results summarized here were negative again in PGA, that is mutation in erythropoietic cells and micronuclei, or chromosome damage in the same cell type. Also in this case, the study was performed in compliance with the guidelines, and the result consistent with historical negative and positive control data. A slightly different situation was for the COMET assay, which was negative with a clear result of high relevance in liver and lung, while inconclusive results were obtained in several tissues, in duodenum, stomach, and kidney. This inconclusive result was mainly due to the very high baseline values, which did not allow an adequate evaluation of data, and which also sometimes were associated with an inadequate response of the positive control. This happens when you have an exceedingly high background. This exceedingly high background may result from technical problems due to the processing of this kind of tissues, and therefore the study was repeated in an independent study, which you see in next slide. The protocol, in practice, only the COMET part of the previous study was repeated in the attempt to get better information. The treatment condition, the protocol also was identical to the main studies, and so we didn't have to spend more time on this. And the result were confirmed to be negative, clearly in liver and lung, and also in kidney, with different levels of relevance. While for the tissues more problematic, again, there was an inconclusive result in duodenum with an exceedingly high baseline and an equivocal result in stomach, in which, again, there was a high background, but also a possible statistical significant increase compared to the concurrent control at some doses, but which was not dose related and largely within the historical control limits. This result, according to the OECD criteria, is considered equivocal, and as an equivocal result, the relevance of this the result was considered limited in the weight of evidence. The fourth study submitted by the Styrene Information Research Center was a mutation test in transgenic animals. In this test, mice, the test animal, are engineered in order to carry multiple copies of a recoverable Lambda bacteriophage shuttle vector in each cell. And this shuttle vector carries a reporter gene, in this case, the lambda C2, in which mutations are detected. Shortly after in vivo treatment, DNA can be recovered by all cells, all tissues in the animals, and DNA extracted, and from DNA, the mutations in the C2 gene identified, as shown in next slide, with a selective method based on the ability of bacteriophage carrying the mutations in this C2 reporter gene to form plaques on a bacterial host under not permissive conditions. In practice, the number of plaques formed reflect the number of mutations occurring during the in vivo treatment of the animals. And this is a powerful method which in principle allows to detect mutations in a variety of tissues, also beyond the erythropoietic cells covered by the PGA method. The protocol of the study is shown in the following slide, and also for this kind of studies there is a dedicated OECD technical guideline, the 488, and the study was largely compliant with these recommendations. Male mice were treated by gavage. I missed to say that there was in preliminary toxicity test evidence of lack of gender-specific effects in the toxicity of styrene, and therefore our studies was performed in the male sex, and this is also according to OECD recommendations. Styrene was given for 28 days and animals sacrificed after additional 28 days. This protocol was specifically designed in order to detect with the best efficiency mutations induced in both slowly and fast replicating tissues. Therefore, in order to cover also the effect in liver, which is a specific interest in case of styrene, and which is in normally a very slow replicating tissue. Glandular stomach, duodenum, lung also were isolated in addition to liver for the analysis of mutations. The study was considered, however, reliable with restrictions, even though the protocol was coherent and consistent with the OECD recommendations, because there was a very limited previous experience using this engineered mouse strain. The big blue system is in fact usually applied in a different mouse strain, the C57 black 6. But in this case, it was considered of specific interest to use engineer mice of a different strain, that is the B6C3F1, because that is the same strain, as I said before, which was responsive to the carcinogenicity of styrene in the long-term carcinogenicity study at the National Cancer Institute. And therefore, it was considered the most relevant animal strain. However, this impact on the relevance of the results and the reliability of the study, because there was a very limited previous experience, and that means that the historical database was very small. And therefore, the study was considered reliable with restrictions. The results were clearly negative in lung, glandular stomach, and duodenum, in which there was no statistical significant increase in mutations at dose with no dose-related trend. The result, however, was considered of limited relevance instead of high because of the restricted reliability of the study due to the absence of robust historical control data. The last of historical control data also impact on the result in liver, in which there was a marginal increase, not those related, but this could not be totally rejected because of the lack of the historical control data, and therefore the result could be not listed clearly as negative, but as inconclusive, and therefore given low relevance. Next slide. Okay, now shortly we have other piece of information coming from the in vitro, from the literature search following the publication of the IARC monograph. The criteria for the screening of literature has been presented already. Go to the result, which are presented here. Out of more than 600 papers, after several screening steps, 5 publications were identified as reporting original data not considered in previous evaluation. However, out of the 5, 2 were inconclusive and given low relevance. These are 2 human biomonitoring studies in which there was no adequate characterization of exposure. 2 were the published version of the unpublished report already evaluated, therefore they did not add new information. At the end, only 1 study, this Murata and others, genes and environment, was identified. This publication is of interest. It is a mutation test using a different transgenic strain of mice in which mutations were identified, assessed in liver and lung. This study, interestingly, was performed by an independent group of researchers, an academic group from the Japanese National Institute for Health. The protocol and the results are shown in the following. And the protocol was also in this case consistent with the recommendation of the CD guidelines, and the mutation in a different transgene, that is LAGZ, were analyzed, determined in liver and lung. Liver and lung selected as main relevant targets because of the liver as a site of metabolism of styrene and lung as the site of carcinogenicity of styrene in mice. And there was administration up to those producing histopathological changes in liver that was considered the highest applicable. And the results showed an outlier which was excluded, but this is usually commonly observed, and these outliers are easily identified, and they result from the clonal expansion of early spontaneous mutations. But once that these outliers was excluded, the result was clearly negative with no increase, and not those related, no statistical significant increase in mutation frequencies in either liver and lung. Therefore, this result was considered negative, and given the reliability of the study, the result was also considered of high relevance. Next slide. Okay, in summary, now all this evidence was summarized in line of evidence. In the weight of evidence, for gene mutation, there was no evidence of mutations in 3 highly relevant studies, including 3 oral studies by the oral route, PGA in mice and rats, and mutation liver and lung transgenic mice, and also a negative result in a limited study in transgenic big blue mice. For chromosomal effects in next, again, no evidence to oral studies of high relevance, and 9 studies using different routes of exposure. 1 single positive result was observed in a study with an intraperitoneal injection. For the third endpoint, that is the primary DNA damage, again, no evidence in 5 studies showing oral or inhalational exposure, including a study with high relevance or 3 oral relevance. 1 positive result, again, was a single positive in studies following intraperitoneal injection. In next, you see, in consideration the term of reference, which specifically ask the EFSA to answer whether EFSA, whether styrene may be genotoxic following oral exposure. The studies using this route of exposure are major relevance, and here there is a compilation of all the available data, which clearly show that consistent negative results were obtained for all endpoints in different tissues in mice and rats. For chromosomal aberration, gene mutation in PGA, micronucleus, comet SA, and transgenic in transgenic rodent systems in two transgene, LAGZ and C2. Well, in addition to this genotoxicity test, also as supporting information, toxicokinetic and human exposure data were considered. For the toxicokinetics, here is a conclusion, very short summary, just to highlight that liver, yes, was confirmed to be the primary tissue responsible for styrene metabolism, while extrahepatic metabolism has a minor role. And the panel noted that this therefore also implies that the liver may be the most relevant target tissue for the assessment of styrene genotoxicity. And in this respect, there were available 3 comet assays considered of high relevance in mice and rats in the comet, in the liver, and a high relevant result in a transgenic rodent system. The systemic availability of styrene oxide reduced by efficient first pass hydrolysis and metabolism. And compared to rodents, humans are less sensitive because of lower capacity to form styrene oxide and higher detoxification efficiency. Therefore, again, the results in mice can be extrapolated and be considered of high relevance for humans, which are expected to be less sensitive. Low micromolar concentration of styrene oxide are measured in blood of rats after oral exposure to styrene at a dose which is comparable to the highest tested in genotoxicity test. And this also provides an explanation on why negative results also are obtained in the studies performed. This is gives some biological plausibility also to the results. And finally, the measure or estimated concentration of styrene oxide in human blood following inhalation of data exposure were in the low micromolar range, which also consistent with the evaluation given by the panel for human studies, human biomonitoring studies. These are shown in next and last piece of information, which were the human study with specific reference to biomonitoring study using genotoxicity endpoints. These were considered important supporting elements in previous assessment also by the IARC, but the FCM panel noted several major limitations in these studies, like the large variability and uncertainty in the extent and profile of exposure, the possibility for co-exposure to other genotoxicants, and the lack of consistency of the results, absence of an exposure response, and the lack of control of relevant confounding factors in most studies. And therefore, also taking into account the conclusion into recent meta-analysis, the panel concluded that the human studies using using genotoxicity biomarkers do not provide sufficient evidence to support an association between styrene exposure and genotoxic effects in humans. Okay, we can skip for the sake of time the last point, which concern the exposure, human exposure. Again, it was confirmed that dietary, but in some cases, especially for smoker, inhalation exposure is a major route. And to go directly to the final conclusions, the panel considered all this piece of evidence that is all available in vivo genotoxicity studies, the critical review of human exposure data and human studies using genotoxicity biomarkers and toxicokinetic data, concluding the following: that the evidence provided by available studies indicate that styrene, although genotoxic of some in vitro system, does not show effects in vivo following physiological route of exposure. Physiological meaning excluding the intraperitoneal route, which is not recommended in OECD guideline for the genotoxicity, in vivo genotoxicity assessment. And in particular, there is no indication of genotoxicity in reliable, robust studies using the oral route in mice and rats, which I remember may be considered from the metabolic point of view worst case compared to humans. Human biomonitoring studies in workers exposed to styrene did not provide sufficient relevant information for the assessment of the genotoxic hazard, and in particular for the hazard posed by oral exposure. And considering all, after reviewing all the available data, the panel concluded that there is no scientific evidence that styrene is genotoxic following oral exposure. That is, there is no evidence that there is a detectable genotoxic effect associated with styrene exposure for any of the endpoints analyzed. And therefore, as a final conclusion, the panel noted that for substances demonstrated to be not genotoxic, as in this case styrene is, according to the EFSA Not For guidance, an SML, a specific migration limit of up to 50 micrograms per kilogram of food, would not be of safety concern. And therefore, in relation to the second question posed by the term of reference, this implies that also the use of styrene in the manufacture of contact material with a specific migration limit of 40 microgram per kilogram of food established by the previous WHO evaluation of styrene in drinking water is of no safety concern either, because lower than the SML of 50 microgram per kilogram of food generally applied to all not genotoxic substances. And this is the last slide for what concerns the assessment of styrene genotoxicity. So I will give again the floor to Sandra Ranieri for the closure of the meeting. Thank you.
Thank you very much, Riccardo Crebelli, and thank you very much, Zainab Al-Raka, for your presentation. We really hope that this presentation could give you a complete overview of the work that was done for the reevaluation of styrene. Now, I would like to spend a few words on the draft opinion that you might have had the chance to read, as it is currently undergoing a public consultation. In this slide, we can provide you the link of this public consultation, and I would like to remind you that it was launched on the 10th of December, and it is still open until the 28th of January, until midnight Central European Time. This is the page that you will meet if you click this link. You can access this page and read the document, which is the draft scientific opinion, where you can find the yellow arrow. And we strongly encourage you to comment and ask a question and really do a good review of this work. As I said, the public consultation, you still have a couple of weeks that you can access. And after that, I would like to close this presentation with the next steps that we expect with this work. We are planning to present the finalized draft opinion after the public consultation, and this means that the draft opinion will include also all the comments and all the comments addressed after the public consultation, and we plan to present this at a meeting of the FCM panel that will be held in March, between the 18th and the 20th of March 2025. This meeting is a plenary meeting that will be open to external observers. So I put down the link in this slide so that you can access it, and in a few weeks it will be completed, possibly with the agenda and also with the link to register. You can register to this plenary if you want to assist directly to the possible adoption, in any case, of the discussion of this draft opinion. And this plenary meeting could be followed online, but also in person. So please follow the instruction that you will find in a few weeks in this link. If the opinion is adopted in the March plenary, what will happen next is that the opinion will be published. We need some time to formatting and setting and adjusting the text. So we expect the publication possibly between April and May 2025. After publication, all the action that will be taken will be risk management action that will not be under the remit of EFSA, and that will be basically guided by the risk managers. Finally, I would like to thank you for following this webinar, and also would like to remind you once again that the recording and the presentation will be uploaded on the EFSA webpage in the next few days, and that you will shortly receive by email a survey from us that we strongly encourage you to fill so that we can improve our services in the future. Thank you very much, and have a good rest of the day.